IPv6 and difference between IPv4 and IPv6 address. Okay, so last time we have done IPv4 header. We have seen what are the different fields and we have seen with the concept of fragmentation. Today we'll start with IP address. So internet protocol address is nothing but a numerical label. Okay, so you might have seen the IP address, that is IPv4 address basically, which we use. That is something like 192.168.10.0, anything like that. So it is nothing but a numerical label which is assigned to every device which is connected to a network that uses internet protocol for the communication. So this works basically on the network layer of the OSI model, or else if you see this TCP/IP protocol suite, here also you can see IP is the major protocol which is there in the network layer of the TCP/IP protocol suite. Apart from that, we have other protocols also, like we have ARP, RARP, IGMP and ICMP. So here we'll see IP protocol. Network layer of TCP/IP supports IP in 4 of the other supporting protocols. So here we have 4 different protocols: ICMP, IGMP, ARP and RARP. And this is ICMP's Internet Control Messaging Protocol. I have given you example of pinging. Then we have IGMP, Internet Group Messaging Protocol. We have Address Resolution Protocol and Reverse Address Resolution Protocol. So these protocols are there for translation of logical address into physical address and vice versa. So it is a transmission mechanism which can be used by TCP/IP protocols. So here we have already seen with the IP datagram last time, all the fields we have seen in this IP header. So we have seen IP is a unreliable and connectionless datagram protocol. So this is very much asked in the oral exams, that what kind of protocol IP is. Like we can distinguish between TCP and UDP. TCP is a reliable, connection oriented protocol. UDP is connectionless, unreliable. And similarly, IP is unreliable and connectionless datagram protocol. That means the packets which we are handling here in the network layer are called as datagrams. So this is a datagram protocol. There is no error checking and tracking over here. And so is the reason for calling it as unreliable. So there is no error checking, no error correction as it is there in the data link layer or the transport layer if you see. Then data is transmitted to destination, but there is no guarantee. There is no acknowledgement which is received as it is received in case of TCP. So we call TCP as reliable and connection oriented protocol. IP must be paired with TCP. Fine. So this is a very important statement here. IP should be paired with TCP so that it becomes a connection oriented reliable protocol. So here we'll see the IP addressing scheme. Now we have seen that there is a physical address which we call as a hardware address, which is given on the NIC, network interface card. This is to identify each device in the network. It requires any logical address that we call as IP address. So addresses that identify the host of its network is nothing but IP address. It is a 32-bit address, and these IP addresses are unique once assigned logically, and they are universal. So here also we have two types that make it unique and universal. So either it is a public domain IP address or a private IP address. Private IP addresses are not universal. They can be same for different organizations, but the public IP addresses are unique and universal. So this is represented in a dotted decimal notation. So here you can see these 32 bits. These are noted in a dotted decimal notation. So we will see these kind of questions which can be asked in your internal assessments or in the oral exams. So how you can convert the IP addresses from binary notation to dotted decimal notation. So this is very simple rather, but you have to practice this so that you can convert it easily in a small amount of time. Fine. So here you have to replace each group of 8 bits with its equivalent decimal number and then add dots for the separation. Fine. So here you have to just go on converting all these 8 bits one after the other, and you will get the dotted decimal notation for these IP addresses. So all of you note down at least one example out of it and try to convert it on your own, and just verify the answer which is given in the slide. I hope everybody remembers the conversion of binary to decimal. So you can take help of calculator also. Fine. And manually, if you are capable enough to have addition very fast, then you can do so. So you have to go on replacing the digits right from the right hand side. 1, 2, 4, 8, 16, 32. Then you have 64, 128. Those bits with 0 as the binary digit, you have to cancel and add the remaining. Okay, so I hope you have written at least one example, and then you have to verify that answer with the given answer. It can be asked on the other way around. The dotted decimal can be given and you have to convert it into its binary representation or binary notation. Fine. So that way also it can be asked. So each number you have to treat separately, and when you represent it in binary notation, you don't have to add the dots, because many students make mistake there. In binary notation, dot is not required. You have to just separate one byte, every byte individually. That's it. Don't add dot in that. Okay. Then the other example, as I told, it can be asked in the other way around. So the IP address in dotted decimal notation can be given, and then you have to replace it with its binary equivalent. Okay, so this can also be asked in this way. So here you have to just remember, you don't have to add dot in between the numbers in binary representation. Okay. Now, how many address classes and blocks are present in IPv4, that we have to see. So there are 5 different classes or blocks which are called as. So we have class A addressing scheme, class B, class C, D and E. So 5 different class addressing scheme we have. Class A address, if you see, it is designed for large organizations with a large number of attached hosts and routers. It is already consumed and cannot be used now. Class B addresses, these are designed for mid-size organizations with 10 of thousands of attached hosts or routers. These are too large for many organizations. Class C address, these are designed for small organizations with a small number of attached hosts and routers. It is too small for many organizations. Class D address, it is designed for multicasting. And class E address, it is reserved for the future use. Fine. So all these 5 addresses, you have to understand which classes are used in practice, okay, and which are not. So class D and class E, these are not used to indicate the logical addresses, because class D is for multicasting and class E is for reserved for the future use. So now, how to find the class in binary notation? So here you can see there are 5 classes A, B, C, D, E. You have 4 bytes first byte, second, third, and fourth, right from the left hand side. Then if your first byte is 0 in the binary notation, you have to readily understand that it is a class A address. If the first byte is 10, then you have to understand it is class B address. First byte 110, it should be class C. Similarly, class D will be 1110 and class E will be 4 ones in the first byte. Okay, this has to be started from the left hand side. So that you have to always understand. So 0, 10, 110, 1110 and then 4 ones. This is for the binary notation. Okay, so in oral exams, the examiner may give you any binary notation representation of the IPv4 address. Okay, and it will that person will ask you to identify which class of IP address it is. So just by looking at the first byte, okay, he will just give you, he or she will just give you the first byte from the binary notation. And so you have to understand which type of IP address, which class of IP address it is. Fine. So this you have to remember 0, 10, 110, 1110 and 4 times 1. So now how to find the classes in decimal notation which changes from 0 to 255. Alright, so we have 32-bit addressing scheme here in IPv4. Just by looking at the first byte, you have to understand which class of IP address it is. So it is divided into 5 different classes according to their sizes. So if you see class A, it is from 0 to 127, whereas 127 is not used in practice. It is used for local loop back. All right. So 127 is not used for logical addressing as such. Class B, 128 to 191. Class C, 192 to 223. Class D, which is used for multicasting, is from 224 to 239. Class E, which is reserved for future use, is 240 to 255. So just as we saw in the binary notation, how you have to understand whether it is of which class. Similarly here, from the first byte in dotted decimal notation also, looking at the first byte, you have to understand which class of IP address it is. So the first byte always tells you the class of the IP address. Okay. So all of you write down these ranges because these are many a times asked in your written exam as well as in the oral exam. Okay, so write down the first byte in dotted decimal notation for all 5 classes here. Okay, can anybody tell me, can I have IPv4 address as 625.125.300.200? Yes, anyone? Can we have an IPv4 address as 600.200.325.125? Anything in the range of 600, 300? Yes. Mehul,
No, ma'am.
why? What is the reason? Why can't I have any IPv4 address in the range of 300 or 400 or anything which is greater than 255? Let it be clear. Anything which is greater than 255. Here it is ranged between 0 to 255, right? So why is this constraint? What is the reason? You might have thought sometime that why the IP4 addresses are only between 0 to 255, not beyond that. Why is the limitation? Anyone? What is the size of IPv4 address? How many bits it consists of?
32-bit.
The 32-bit, they are represented in 4 octets, 4 bytes, each of 8 bits. So 8 bits, how much value it can take in binary? 2 raised to 8, isn't it? So 2 raised to 8 is 256. So if you start from 0, it becomes 0 to 255. All right. So each byte can take values only from 0 to 255. Hence, we cannot have the IP address greater than 255 value. All right. So this is very important reason. It can be asked anywhere in your interviews or in your oral exams. So why is the range limited up to 255 only? So we have 32-bit IPv4 address which is represented in 4 bytes. Each byte consists of 8 bits. So the binary value it can take is 2 raised to 8. That is the decimal value maximum is 2 raised to 8. That is 256. We start from 0. So 0 to 255. Okay. So this much is the size limitation here that you have to understand. Now, as I told you, you have two different types of IPv4 addresses, private IP address and public IP address. So here you can see there is a class B which is used for private IP addressing scheme. Class A which is used the first row. Here it is not indicated. So first row is class A, second row is class B and third row is class C. I will just modify the PPT before uploading in GCR. Okay, A, B and C it is the 3 rows which are indicated. So class A is starting IP address is from 10.0.0.0. Ending IP address will be 10.255.255.255. Okay, that means the host ID is 10.0.0.0 and the net ID is 255.255. That means all these number of hosts it can accommodate. So how many hosts it can accommodate? The maximum number of hosts class A can accommodate and those are 16,777,216. So all these hosts can be accommodated in class A. Then if you talk about the private IP address at class B, so its starting will always be 172.16.0.0. Okay, and then we have first we have net ID and then we have the host ID. So host ID is 172.31, that is 255.255. So how many hosts? 1048,576. So these many hosts it can accommodate. So that is why it is told that B is for mid-size organizations, class A is for large organizations and class C is for small organization because it can accommodate only 65,536 number of hosts. What is the starting IP address in class C? 192.168. Okay, so that is the net ID. So all our IPv4 addresses which we are using in college, these are class C private IPv4 addresses. Fine. So you might have observed always you will see 192.168 series in college. So these are for subnetting in LAN addresses. They are used class C private IPv address. Okay. So these are the difference between public and private IP addresses. So any address in the range 10 dot, it becomes the private address for class A. Any address starting with 172.16 is the private IP address in class B. Any address starting from 192.168 is private IP address in class C. Okay. Now you have to find out the class of each address here. So just by looking at the first byte, you have to understand the type of class. So if you see in the first example A, the first bit of the first byte is 0. Okay. The first bit of the first byte in A is 0. So if the first bit is 0, it is a class A address. Okay, you don't have to calculate also that what is the range, whether it is in 0 to 127 range. Don't calculate that. Just look in the first byte, what is the bit indication. So if the first bit is 0, it is class A. In example B, you can see the first byte. So in first byte, you see 4 ones at the starting point. So 4 ones, that means it is class E address. Okay, so this is how you have to understand the class of each address just by looking at the first byte. Now, in the dotted decimal notation, if it is given, then how to find the class of each address. So here again you have to look at the first byte. So in A, the first byte is 227. Okay. So first byte is 227. It is between 224 to 39. So it is class D. In example B, it is 252. First byte is 252. So it is between 240 to 255. So class E. And in example C, the first byte is 134. It is between 128 and 191. So it is class B IP address. Okay, so just by looking at the first byte, you have to tell this. Now, apart from private IP address and public IP address, we have one more classification of IP address depending on the assignment of IP addresses. So here we have two types, a static IP address and dynamic IP address. Now, static IP address, as the name tells, it is manually inputted by the network administrator. When there are small networks, generally the network administrators use static IP addressing scheme because it is manageable for the small networks. It requires careful checks to avoid duplication. That is one drawback of the static IP address. But at the same time, it has advantage that uniquely that IP address will be given and it will be 24/7 available for that particular host. Okay, so host will not remain any time with unavailability of IP address. So that is the advantage. But at the same time, it is having a drawback that it requires careful checks so that the duplication will not be happening. Dynamic IP address, as the name tells, assignment is given by the server when the host boots. So it is not available 24/7 to the same host. It changes because here there is a pool of IP address from which it has to be taken. So as and when the IP address is free by any other particular host, it can be assigned to another host which requires that. So the assignment is not by the network administrator manually, but it is by the server when the host boots. Here the examples are boot TP, and then we have DHCP, Dynamic Host Configuration Protocol, which we are going to learn in this subject. So it is derived automatically from a range of IP addresses. Now, when the organizations are large, you cannot give a single IP address to each and every host. You have to you have to make use of small amount of resources to its optimum utilization. So what can be done? Small number of IP addresses, they can be shared among the large number of hosts. So as and when suppose one particular host is not using internet, it is in the shutdown mode. So in that case, the IP address which was assigned to that host can be automatically shifted to other host which requires it. So this is derived automatically from a range of addresses. So small amount of IP addresses can be shared among large number of users. The duration of lease can be negotiated, and then the address is released back to the server. So as and when required, the lease is negotiated. As and when not required, the address is released back to the server so that server can assign it to the host which requires it. That is dynamic IP addressing. Another concept here which we have, which is very important in IPv4 addressing or IP addressing as such, is subnetting and supernetting. Subnetting, as I said, dividing small number of IP addresses in large number of hosts. So dividing the network into several smaller other networks which are called as subnets, with each group having its own subnet IP address. Okay, so that you can share the IP address among large number of users. Here, the rest of the internet looks like a single network, and the routers inside and outside the organizations, they route the packet based on main network address. So here we have to concentrate on what is a net ID and what is the host ID. So local routers, they will route within the subnetted network using the subnet address. So what is the subnet address given? According to that, the routers have to take decision where they have to route the particular packet. The host portion of the address. Now, as I told you, in every IP address, there are two parts. There is a net ID and there is a host ID. Okay, if you see in class A, the first byte is the net ID, the remaining 3 bytes are the host ID, and that is why you have 2 raised to 24 number of host accommodation in class A. All right, 32 minus 8 because first byte is for net ID, remaining 24 bits for the host ID. So 2 raised to 24 number of host can be accommodated in class A. Class B, first 2 bytes are for net ID and the remaining 2 bytes are for host ID. So how many hosts it can accommodate? 2 raised to 16. Then class C, first 3 bytes for the net ID and remaining 1 byte or the single fourth byte is for the host ID. So class C can accommodate 2 raised to 8 number of hosts. Alright, and hence we say class C is for the small organizations where less number of hosts are there. So here it means IP address have 3 levels: main network, subnet ID, and then the host ID. So we have one concept here again which is called as subnet mask. What is a subnet mask? It is nothing but a 32-bit here which we have the IP address. It consists of zeros and ones which indicate that which bits of the IP address are subnet number and which bits are the host number. The subnet mask when ANDed, okay, so you have to logically AND it with the IP address, it gives the subnetwork address. So we have to solve various numericals based on this. Some we will solve today. I have some numericals in the slide that we'll do today, and the remaining ones we will do in class. So here the subnet mask, you have to AND with the IP address. So we will see with some numericals. First, you understand what is the concept behind this. So masking, as I said, it is a process that extracts the IP address. Now the extraction, how it can be done? It can be done by looking at the IP address, how many net ID bits are there and how many host ID bits are there. So you can have boundary level masking or you can have non-boundary level masking. So boundary level masking, here the mask numbers are either 255 or 0. So you can find the subnetwork address very easily. But if the mask numbers are not between 0 to 255, then you have to bitwise AND it with the IPv4 address, and then you can find out the subnet address. Subnetting is nothing but dividing a large number of network or large size of network into small networks, which are called as subnets. Exactly opposite of that is your supernetting. So supernetting is combining several other networks, several small networks into a one larger network, because you have to have address reduction.